Now we know that tangents are a straight line and they just touch a curve at one point, and the gradient of them tells us what the gradient of the curve actually is at that point. But what about a normal? This is something we haven't seen before. Now a normal is a line that's perpendicular to the tangent. So we know that a derivative lets us find the gradient of the tangent at some point P. And a normal is then a line that's actually at right angles to the tangent and also going through the same point. So let's just imagine what this might look like. If we've got some curve and we find the tangent at some point P, and that's a straight line that just touches that curve once at that point, then the normal will be at right angles to that, and we'll go along like this. So here we've got the normal, and here we've got the tangent, and they are perpendicular to one another. Now, we've already learnt before that perpendicular lines have this special property where if you multiply their gradients together, you get -1. So if you know the gradient of the tangent and you want to find the gradient of the normal, you can put the gradient of the tangent in as m1 and then solve this equation to find what the other gradient, or m2, would be. There's also a quick way. You can also flip it upside down, in other words, find the reciprocal of it, and just change the sign. So in other words, if you found that the gradient of this tangent here was, say, 3, then you'd be saying 3 times my other gradient is equal to -1, and your gradient would then have to be -1/3. So look at how 3 and -1/3 are related to each other. 3 is really 3/1. We've flipped it upside down, and if it was positive, the normal will be negative. And if the normal's negative, then the tangent will be positive, vice versa. Okay, so our example here, find the equation of the tangent and the normal to y equals x squared plus 3x at this point. Now, I've said here, once you have the gradient and you have a point, you can use point gradient form to get the equation of the tangent or the normal. Now, what is that? You'll remember this equation, y minus y1 equals m outside of x minus x1, where x1, y1 is your point, and m is your gradient. Okay, so the first thing we need to do here, we need to find the gradient of the tangent. So we do that by first differentiating y equals x squared plus 3x. So because I was given y, I'm going to write dy dx as the form of the derivative. And differentiating x squared, I get 2x. Differentiating 3x, I get 3. Now, I'm interested in finding what the gradient is of the tangent when x is 2. So I need to explain what I'm doing. When x equals 2, dy dx equals, now I need to sub 2 in here, so 2 2's are 4, plus 3 is 7. So it's quite steep at that point. The gradient will be 7. So that's telling me that the gradient of the tangent at this point is 7. So now I can sub it into y minus y1 equals m outside of x minus x1. I have my point, 210. I have my gradient, 7. So I go y minus the y value, 10, equals my gradient, 7, outside x minus the x value of my point, which is 2. Now, if it asks you for the equation in general form, go ahead and put it in general form. If it hasn't specified what form it wants, then you can put it in whatever form you like. So gradient intercept form would be fine. I'm going to expand these brackets and then add 10 to both sides so that I've got y equals 7x. Now 7 times -2, that's minus 14. But if I add 10, I'm going to have minus 4. So y equals 7x minus 4. I've done the first thing, which is finding the equation of the tangent. That's done. All right, now to find the equation of the normal. Let's continue working over here. If the tangent had a gradient of 7, then I know that I can flip that upside down and get 1/7, and change the sign to get -1/7, and I can just write that down. The gradient of the normal equals 1/7. And if I want to prove it, I can show 7 times -1 equals -1. That's just like a little proof to show anybody who's looking at my work that I know what I'm doing, and I've got a reason for this gradient. Okay, so now I need to just throw it into this same formula, y minus y1 equals m outside of x minus x1. Now, you'll notice I'm writing it down each time because I'm being really clear about what I've done. And also, if you write this every time, after a while you'll remember it and you're not going to forget it. It also just helps to make sure you haven't made any mistakes. So my y1 is still 10. And here my gradient is now minus 1/7 and x minus 2. So same as before, I'm going to get y by itself. I'm going to multiply out my brackets. I've got minus 1/7 x, or you can write minus x on 7, same thing. And I've got plus 2/7 plus 10. So I've got plus 10 and 2/7. And now I've got the equation of my normal. So now it might be really clear to just explain what I've got. Therefore, tangent equals is this, maybe put a dot dot, and therefore normal is that. Just so it's really clear on your answer what it is that you found. You could also just write them out again, nice and simply.